Hey, welcome to Stoichiometry and the Mole concept. So far, we have looked at introduction to the mole. We also looked at calculations that involve equations. We looked at gas volumes in the previous video. In this video, we're going to take a look at other calculations. So on these other calculations, it's going to be delivered into two videos so that it's as comprehensive as possible. So this is the first video. There's going to be video 2. So the first quantity we're going to learn how to calculate is called concentration. Hope you are concentrating. So what is concentration? So concentration is just the amount of solute dissolved in a unit volume of the solution. So a solution that has more solute is said to be more concentrated than a solution that has less amount of solute. How do we calculate concentration? First, the units for concentration are grams per decimeter cubed or moles per decimeter cubed. So there are two types, there are two ways of calculating concentration. One involves measuring the number you get in grams per decimeter cubed, then the other one in moles per decimeter cubed. So the formula for concentration, if we're measuring the one for grams per decimeter cubed, is mass of a solute over volume of a solution. Mass of a solute over volume of a solution. Then the other one, which is of course the one that involves moles per decimeter cubed, is moles of a solute over volume of a solution. This second one is called molarity. This second one, which is for moles per decimeter cubed, is called molarity. So the units for molarity are first the formula. If it's for molarity, it's usually written like this: N over V. So the units are moles per decimeter cubed, as I said, but sometimes they use just a big M to show the molarity of a solution. So for example, a solution that has a concentration of, let's say, 20 moles per decimeter cubed is going to be written as 20 M. So the M suggests that that is concentration expressed in moles per decimeter cubed, or molarity. So let's take a look at an example. A solution of glucose contains 0.45 grams of glucose in 0.075 decimeter cubed of a solution. Calculate the concentration of glucose solution in grams per decimeter cubed. So we have been given the mass and the volume. So they want us to calculate the concentration of glucose in grams per decimeter cubed. So we recall the formula. Concentration in grams per decimeter cubed is mass over volume. So get the mass of the solute, which is 0.45 grams, and the volume of the solution, which is 0.075 decimeter cubed. When we punch this, we're going to get 6.0 grams per decimeter cubed. The second question is find the concentration in mole per decimeter cubed of a solution of sodium hydroxide if it contains 3.5 grams of sodium hydroxide in 100 centimeter cubed of a solution. So this question, of course, they want the concentration in moles per decimeter cubed, but they have given us the mass. So this mass has to be changed to moles. Again, the volume they have given us is not in decimeter cubed, it is in centimeter cubed. So this has to be converted to decimeter cubed. That's when we can apply the formula for molarity, or concentration in moles per decimeter cubed. So let's start with changing the mass to moles. So now number of moles of sodium hydroxide is equal to mass over molar mass. So mass is 3.5 grams, molar mass is 40 grams per mole. When we divide, we get 0.0875 moles of sodium hydroxide. Next, this volume has to be converted to decimeter cubed. So the relationship is 1000 centimeter cubed is equal to 1 decimeter cubed. Decimeter cubed, the other word for decimeter cubed is liter. So 1000 centimeter cubed is equal to 1 liter, which is 1 decimeter cubed. So this decimeter cubed, so we have this relationship. The next is to convert 100 centimeter cubed to decimeter cubed. So on this side, we're going to write 100 centimeter cubed. Then we write x here, since we're looking for the decimeter cubed equivalent of 100 centimeter cubed. So 100 centimeter cubed x. So when we do cross multiply, we're going to get and 1000 times x is going to be 1000 x. 100 times 1 is going to be 100. We can divide both sides by 1000. We're going to get 0.1 decimeter cubed. So when you are given any value in centimeter cubed, just divide it by 1000. You're going to get the decimeter cubed equivalent of that number. So you won't have time to do this calculation, so you have to learn to do this calculation in your head. If I've been given 5 centimeter cubed, divide it by 1000, it's going to give you 0.005 decimeter cubed. Now that we have that, we can record the formula for molarity. So molarity is number of moles over volume. Number of moles which you have calculated to be 0.0875, and the volume is 0.1 decimeter cubed. When we divide these two, we're going to get 0.875 moles per decimeter cubed. Hope my calculator is saving me well here for this to be the answer, 0.875 moles per decimeter cubed. Okay, so I was just trying to verify. Yes, it is 0.875 moles per decimeter cubed as the molarity. Then we're going to learn a very important technique, which is converting molarity to concentration in grams per decimeter cubed. So it's possible to get molarity from concentration in grams per decimeter cubed. So the formula is molarity is equal to concentration in grams per decimeter cubed over molar mass of the solute. If you have the molar mass of the solute, you can just divide the concentration in grams per decimeter cubed by the molar mass. You're going to get the molarity. So here's an example. 4.5 grams of anhydrous sodium carbonate was dissolved in distilled water and made up to 500 centimeter cubed. Express the concentration of the solution in terms of A, grams per decimeter cubed, B, moles per decimeter cubed. So we're going to start with grams per decimeter cubed. We have been given the mass and the volume, so this should be easy. The job is just to convert this to decimeter cubed. We're not going to do to show the actual conversion, because this is something that you should learn to do in your head, converting from centimeter cubed to decimeter cubed. So here's the solution. So concentration, we know it's mass over volume. So this 500 centimeter cubed, what is it in decimeter cubed? You divide this by 1000, it's going to be 0.5 decimeter cubed. So we're going to have concentration 45 grams over 0.5 decimeter cubed. When you divide, you're going to get 9.0 grams per decimeter cubed as the concentration of sodium carbonate expressed in grams per decimeter cubed. Now the next question is moles per decimeter cubed. So there are two ways to go about this. The first is you can convert this to number of moles. Then when you are done, when you convert this to number of moles, then you can go this one we know already how to convert it. So once you have the number of moles and the volume decimeter cubed, then you can calculate this. Then the shortcut is the one we are from learning here. So in the shortcut, you just have to use the formula where you divide the concentration in grams per decimeter cubed with the molar mass of the solute being this here. So molarity is concentration over molar mass of solute. So the concentration is 9.0 grams per decimeter cubed, and the molar mass of sodium carbonate is 106 grams per mole. For those who still can't figure out how this number comes about, of course you get the mass number of sodium, you multiply it by 2, then you add it to the mass number of carbon, then you add it to the mass number of oxygen multiplied by 2. So it's 2 times mass number of sodium plus the mass number of carbon plus 3 times mass number of oxygen. So once you have that, you can get your molarity as 0.085 moles per decimeter cubed. So here's an example. calculate the mass of calcium hydroxide required to neutralize. So this example is trying to portray calculations that involve equations. Remember what we used to do in the previous subtopics when we then a topic, for example, how to get moles of a substance, we could see how to do the same from an equation. So here is the reaction. So um, how do we get various parameters using the knowledge that we have acquired if it is in an equation? Calculate the mass of calcium hydroxide required to neutralize 2.5 decimeter cubed of 0.5 uh, moles per decimeter cubed of hydrochloric acid. So we have calcium hydroxide here. So it's going to participate in a neutralization reaction with hydrochloric acid. By now, since we did acid and bases, we should be able to write the equation for this, the neutralization reaction. So this is the neutralization reaction. It's not always that you can be given, but here, of course, it has been given. So this is the reaction. Calcium hydroxide reacts with hydrochloric acid from calcium chloride and water. So the question is, calculate the mass of calcium hydroxide that is needed to neutralize 2.5 decimeter cubed of 0.5 moles per decimeter cubed of hydrochloric acid. So how can we know the mass? So simple. This is what we learned. It's just that the number of moles of hydrochloric acid that participate in this reaction has been written in a different way. How? They have given us the volume. They have given us the molarity here. So from these two values, we can get the number of moles. We can tell the number of moles of hydrochloric acid that that's going to be neutralized. Once we know the number of moles of hydrochloric acid that's going to be neutralized, we can use more ratios to we can use more ratios to determine the moles of calcium hydroxide. Then once we know the moles of calcium hydroxide, we can now calculate the mass of calcium hydroxide. With that being said, so we can first start with getting moles from molarity. So molarity is equal to number of moles over volume. When we solve for number of moles, we're going to have molarity times volume. So molarity is 0.5 moles per decimeter cubed times volume, which is 2.5 decimeter cubed. When we multiply, we're going to get 1.25 moles of hydrochloric acid. So 1.25 moles of hydrochloric acid are going to be neutralized. Then we're going to use more ratios to tell the number of moles of calcium hydroxide that are going to participate in the neutralization reaction. So moles of calcium hydroxide, more ratios. One more, according to this equation, 1 mole of calcium hydroxide requires 2 moles of hydrochloric acid. What about 1.25 moles of hydrochloric acid? How many moles of calcium hydroxide is it going to react with? So we can do cross multiply here. And do cross multiply, we're going to have x. That is, we do cross multiply and divide both sides by 2 moles of hydrochloric acid. We're going to have 1 moles of calcium hydroxide multiplied with 1.25 moles of hydrochloric acid divided by 2 moles of hydrochloric acid. So when we do that, we're going to get 0.625 moles of calcium hydroxide. So the number of calcium hydroxide needed, the number of moles of calcium hydroxide needed is 0.625 moles. With that being said, what is the mass? How can we tell the mass of calcium hydroxide from the number of moles? We know the formula. Mass of calcium hydroxide, simple. We multiply number of moles times molar mass. So this is that equation we learned in the earlier videos for number of moles, which is equal to mass of a substance divided by the molar mass. But we have made mass subject. So we know the number of moles and the molar mass of calcium hydroxide. We're talking about the mass number of calcium plus 2 times the mass number of oxygen plus 2 times the mass number of hydrogen. So we're going to have 0.625 times 74. So the molar mass of calcium hydroxide is 74 grams per mole. When we multiply, we're going to get 46.25 grams of calcium hydroxide. Sorry, I ran out of space, but this is how we get the number of calcium hydroxide, the mass of calcium hydroxide that's going to participate in this neutralization reaction. Next, we look at a concept called percentage by mass of an element in a compound. So if you have been given a compound, there's a way to calculate the percentage by mass of that element in that compound. The formula is you have to know the number of atoms, then you multiply by the relative atomic mass of that element. So for example, if it's sulfur, or let's say hydrogen, the relative atomic mass of hydrogen is 1. So if in a compound there are 3 atoms of hydrogen, you multiply that by 3, then you divide by the molar mass of whatever compound it is. You multiply by 100%. Here's an example. Calculate the percentage by mass of each element present in sodium carbonate. So this is sodium carbonate. They want us to calculate the percentage by mass of each of the elements. We're talking about sodium, we're talking about carbon, we're talking about oxygen. There are 3 elements in sodium carbonate. So percentage by mass of sodium is number of sodium atoms. Number of yes, of course, it's number of sodium atoms times relative relative atomic mass of sodium divided by the relative molecular mass of this compound. So there are 2 atoms of sodium, each with the mass number 23. So over what is the relative molecular mass of the compound? So we're talking about 2 times 23 here, plus carbon, of course, is 12. There's 1 carbon atom, so it's going to be 1 times 12, plus oxygen. The molar mass, the mass number is 16, and there are 3 oxygen atoms, so it's going to be 3 times 16. That's what we have here. With that being said, 2 times 23 is going to give us 46, and on the bottom, 2 times 23 plus 1 times 12 plus 3 times 16 is going to give us 106. And when divide and multiply by 100%, it's going to give us 43.3% as the percentage by mass of sodium in sodium carbonate. Let's look for, so for carbon we do the same. So carbon mass number 1 times 12. Note that the molar mass of the relative molecular mass of the compound won't be changing, it's just the same. With that being said, we're going to have 12 on top and 106 on the bottom times 100%. It's going to give us 11.3%. Next, percentage by mass of oxygen. There are 3 oxygen atoms multiplied by 16, which is the relative atomic mass of oxygen. We're going to have this, so 3 times 16 is going to give us 48 over 106 times 100%. This will give us 45.3%. Next, we look at it's the same concept but extended. So I've looked at percentage by mass of an element in a compound. Now we're going to look at percentage by mass of water in another compound, usually a hydrated compound, a compound that has water in it. So I want to know the percentage by mass of water in that compound. So the formula is nearly the same. Percentage by mass of water is just the number of moles. So I've just seen that my spelling for number here is fine, supposed to be u, and I've made the same mistake in the previous formulas, so it's just supposed to be u here, number. So number of moles of water times relative molecular mass of water divided by relative molecular mass of the compound times 100. So the thinking is the same as you're going to see in an example. So calculate the percentage by mass of water in sodium carbonate crystals. So sodium carbonate crystals, the formula is this. They want us to calculate the percentage by mass of water. So we just need the number of moles of water. So here there are 10 water molecules. Then the relative molecular mass of water. So in short, you view water like it's one element, where in the previous case we were calculating the relative atomic mass, but here we calculate the relative molecular mass since it's a molecule. So the solution is simple. Percentage by mass of water in sodium carbonate is 10 times 18. Since there are 10 moles of water and the relative molecular mass of water is 18 over, so for the entire compound we have 2 times 23 plus 12, which is carbon, plus 3 times 16, which is oxygen, plus 10 times 18, which comes from water. So we have 286, and on top 10 times 18, so times 100%, we are going to get 62.9%. So finally, we look at mass of element in a sample. Mass of element in a sample. They have given you a sample. Let's say it's 20 grams of sodium carbonate. What is the mass of sodium in that 20 grams of sodium carbonate? That's the kind of thinking we're going to look at here. It's not percentage by mass, but just the mass of an element in a sample. So mass of an element in a sample is relative atomic mass of the element divided by relative molecular mass of the compound times mass sample. So this sample we're talking about is of course a compound, so it's going to have it's going to have a mass, but you need to get relative molecular mass of the compound, is the one that you're going to use here. So let's take a look at an example. Calculate the mass of copper in the 2 grams of copper 2 sulfate. Calculate the mass of copper in the 2 grams of copper 2 sulfate. So you have copper 2 sulfate, the 2 grams of copper 2 sulfate. So they want you to calculate the mass of copper in that 2 grams of copper 2 sulfate. So here's the solution. We just apply the formula. So mass of copper in copper 2 sulfate is equal to relative atomic mass of copper over relative molecular mass of copper 2 sulfate times mass of copper 2 sulfate. So relative atomic mass of copper is 64 divided by relative atomic mass of copper 2 sulfate is 160. Also, copper is 64 plus sulfur is 32 plus 4 times oxygen, which is 16. When you add that, you're going to get 160. So times the mass that have been given, which is 32 grams. So when you solve this, you're going to get 12.8 grams as the mass of copper in 32 grams of copper 2 sulfate. So this marks the end of this subtopic. In the next and last part, we're going to take a look at percentage yield, and so empirical formula and molecular formula, and that's going to conclude this topic. So this has taken us about 22 minutes. Wow. Anyway, happy solving.